just cut out the beginning portion.
Thank you, ma'am.
And plug in my laptop, I don't want it to die in the office. It's a lesson. Plug it in.
Jen, you get your recording? Say hi to the say hi to
Okay, good morning, class. My name is Mr. Cano, and I'll be giving a lesson today. The lesson is about adding and subtracting fractions. So we're going to get a little bit more in depth, not just regular numbers, but for now, if you could all go to the first page, we're going to work on the first problem together. So, we're going to add a fraction, 2 over 2/3 and 4/3. How do we add fractions?
Oh, it's not open. Yeah. Sorry. Have to open the activate fire.
Okay. So how do we add fractions, Simon?
Honestly, I can't remember.
Huh?
I can't remember.
You can't remember? Okay, does anyone want to volunteer? How we could add fractions? Okay, same denominator. So 3 and 3, same denominator? Yes? And then what do we do with the numerators?
Yeah.
We add the numerators, okay? So then that's 2 plus 4 over 3, which is 6 over 3. Okay, is that it? Or can we do something else too?
Simplify it.
Can we simplify it? Okay. What can we simplify it to? To 2? Okay. And that's correct because 3 fits into 6 2 times. Now, second problem. Let's go with Lionel. Dinesh. Second problem. How do we do it? What should we do first? Okay. Well, first we make sure they have the same denominator, which they do. And then yes, we subtract the numerators. Keep the denominator the same. 1 over 7. Can we simplify this? No? Okay. Now, let's say we have different denominators. Go with Raymond. We have a problem. We're adding 2 fractions, so they have different denominators. What do we do?
You gotta get the same denominator.
Okay. And how do we find or how do we get the same denominator?
You can multiply the fraction by the denominator.
Okay. So could you elaborate?
7 over 9 times 4 over 4.
Okay. So we multiply times 4, multiply times 4, and we get 4 times 7 over 9 times 4 plus And what do we do to the 3 and the 4?
You multiply by 9 over 9.
We multiply by 9 over 9, which is 3 times 9 over 4 times 9. 4 times 4 is 28. 9 times 4 is 6. 9 times 3, 27. 4 times 9, 36. Now they have the same denominator. What do you do now, Raymond?
You add 28 plus 27.
Okay. 28 plus 27. And because the denominators are the same, we keep the denominator. And that equals to 55 over 36. Can we simplify this? No. We can't simplify this further, so this would be our answer. Okay. Can we continue to the second problem? Does anyone else copy this down? No? Okay. Now, the second question, 2 over 3 minus 6 over 11. Let's go with Saul. So how would we subtract fractions?
The same as adding, but we get the common number.
Okay, so we get the same common denominator. What would the common denominator be?
Multiply to 2 over 3, 6 over 11,
Okay, so Saul said multiply by 11 over 11. Multiply 2 over 3 by 11 over 11, and multiply 6 over 11 by 3 over 3. From there, we'll have 2 times 11 over 3 times 11. Minus 6 times 3 over 3 times 11. 2 times 11 is 22. 3 times 11, 33. 6 times 3 is 18. 3 times 11, 33. Now they have the same denominator. What do we do from there? You just subtract them, right? 22 minus 18. Same denominator. The denominator of the difference is going to be the same. And then what is 22 minus 18? 4 over 33. And because you can't simplify it anymore, that would be the answer to number 2. Okay, now let's go on to the next page. We're going to find the least common multiples of monomials and polynomials. Does somebody, could someone give me an idea of what they think least common multiple means? Or what they think least common multiple is?
The same number, if you multiply those two, like the common, I don't know how to
Okay.
explain it, but.
No, you're
Yeah.
you're in the ballpark. So least common multiple is a multiple of the numbers that we have, but the lowest one. So let's say we have two. Let's say we have 2 and give me a number. Give me a number. Huh? 5? Okay, 2 and 5. The multiples of 2 are 2, 4, 6, 8, and so on and so forth. Oh, well, I should probably write it down. 8, 10, 12, 14, so on and so forth. Multiples of 5, 5, 10, 15, 20, 25, so on and so forth. The least common multiple of 2 and 5 would be what? Would be 10. Why? Well, of all the multiples of 2, all the multiples of 5, 10 is the multiple with the lowest value. Okay? Now, we're working with monomials, 4x and 5y. How do we figure out the least common multiple? Well, best thing to do is to factor out the values. So we have 4x. You could take out the 4, make it 2 times 2, and then you can't factor anything in from x, so you just have an x. 5, y, well 5 is prime, so you can't factor anything out of 5. You're left with just 5, y. Now the least common multiple, you take the different factors that you came up with. So we came up with 2, x, 5, and y. 2, x, let me write 5, x, and y. These are the different factors that we have in 2 and 4, and we have in 5. Then we see, okay, what's the most amount of times that 2 comes out within these two monomials? Well, 2 comes out twice. In 4, 5 comes out once in 5y, x comes out once in 4x, and y comes out once in 5y. 2 squared is 4. 5 to the first power is 5. X to the first power is x. Y to the first power is y. Then we just simplify it further. 4 times 5. We get 20 x, y. And this would be the least common multiple of 4x and 5y. Okay? Is there any questions? Do we need a little bit more time to write down the steps to find the LCM, the least common multiple? Or is everyone written down? Okay. So let's go on to the second one. My bad. We have 6xy. Can we factor out, or what factors can we get from here? Well, 6 is a composite number. Composite means that it has more than, composite means it's not a prime number, so it has factors greater than 1 in itself. So what are some factors of 6? Well, we have 2 and 3. When we're doing this part of the process, we would try to choose prime numbers to get out. That when we're trying to factor out of the monomial that we're working with. So x is to the first power, so we write x to the first power, y to the first power, right to the first power. Then we got 15x squared. 15x squared. 15, it's a composite number too. What are some multiples of, or not multiples, but some factors of 15 that are prime numbers? 3 and 5. We have 3 and 5. X squared, you write it x squared. 9x y to the fourth. Nine x y to the fourth power. Okay. 9 is also composite. The factors 3 and 3, both of which are prime. So we have 3 and 3. X, you write it x, and y, you write y to the fourth. We're trying to find the least common multiples. The least common multiple of these three monomials. Okay, well, we need to list the factors. What are the factors that have come up here? Well, we have 2, we have 3, we have 5, we have x. Now, because we have an x, we look to see where it came out the most times. Well, it came out once here, twice here, and once here. So the exponent that we write, well, yeah, the exponent that we would write on the x would be the greatest exponent within these monomials. So it would be x squared. And then y, you do it to the fourth power because it came out 4 times in 9x y to the fourth. 2 came out once, and the most times it came out was that one time in 6x times y. So you write 2 to the first power. 3 came out once here, twice here. Okay, because it came out twice here, you would write 3 to the second power. And 5 came out once in 15x squared. So you write to the first power. And then from here, this is just the prime factorization of the least common multiple. So to actually get the least common multiple, we would simplify this. So 2 to the first is 2, 3 to the second is 9, 5 to the first is 5, and then x squared, y squared. Okay? 9 times 5 is 45, times 2, 90. Do we agree with that? 9 times 5 is 45, and then times 2, or, oh, yes. My bad, this was supposed to be to the fourth power. But 90x squared times y to the fourth is the least common multiple of 6xy, 15x squared, and 9x y to the fourth. Is there any questions?
How come for the final answer you put x times y instead of like both of them together?
Or when we write when we're writing variables, this means the same thing as x times y. When there's no dot or multiplication symbol, which is normally looks like an X. If you just have two variables right next to each other, let's say W, V, it's implied we're doing multiplication, the operation. From my understanding, the reason they don't do the X is because some people might get confused with the variable X. But it's implied that this is multiplication. I sometimes switch to using the dots, but it means it has the same meaning. It's multiplication of the variables. Any other questions? Now, to the third problem. We have 2x squared minus 2 and x squared minus 3x plus 2. To find the least common multiple for here, we need to factor out, and we need to factor out all possible values here so that it's no longer one big number, but the factors of these polynomials. Now, we have here 2x squared minus 2. Let's see. We need to get the factor of this polynomial. What is something that we could factor out of these two terms and write it on this side? And multiplication 2. So we factor out a 2 from here. What are we left with? X squared minus 2. Minus 2. Actually, it says 1. Why would you say it's 1 actually? Okay. Ashley says because you factored out the 2 from both of them, the 2 that was a coefficient there is gone. That means you take out, or you divide this term by 2, which comes out to 1, and then you could just test it. Just multiply x squared minus 1 times 2, you get back 2x squared minus 2, which is what we started off with. Okay? So you could also test to make sure that your factors are correct by just distributing the factors that you just came up with. So then, yes, our factors would be 2 and x squared minus 1. You can still work with 2x minus 1. A couple weeks back, you guys were working on factoring out of polynomials. So, Ashley, could you help me find the factors for x squared minus 1? Okay, well, let's work on it together. Either way. So, we need to find 2 x's that when multiplied together will give us x squared minus 1. Now, 1 is a prime. Or, sorry, it's not prime. 1 only has factors 1. Right? So, we could write here 1 and 1. And then when we multiply these two, we need to make sure that there is no b in the middle. Let's try negative, negative, and distribute. Come up with x squared minus x squared minus x minus x plus 1. We combine like terms, come up with x squared minus 2x plus 1. That is not what we wanted. We wanted x squared minus 1. So, one of these two signs need to change. They're the same number essentially. So whichever one you turn positive, you can still try it out, be the same. But then when you distribute, one of them becomes positive, and then 1 times 1, or positive 1 times negative 1, you come out with negative 1. Positive x, negative x. You have x squared minus 1. And that is what we were trying to look for right here. So then this, the factors of x squared minus 1, are x minus 1, x plus 1, and the 2 is still there. Because we're saying that this has factors of x squared minus 1, x plus 1, and 2. Now x squared minus 3x plus 2. There's no the coefficient of x squared is 1. Coefficient here is 3. Coefficient here is 2. There's no, the x here is squared, x here is to the first power, and there is no x here. So we can't factor out a number. We can't factor out a variable. This is a polynomial to the second degree. So there's two solutions we come out of that we could make, that we could have as factors of x squared minus 3x plus 2. So we're looking for two values that when we add them together, we end up with negative 3, but when multiplied together, we end up with 2. 2 as factors of 1 and 2. We need to find whether this one is positive or negative. We need to figure out whether this 2 is positive or negative. Now here, our 2 is positive. To get a positive 2, we could multiply two positives, 1 and 2, or we could multiply two negatives, negative 1 times negative 2. Now when we add these two values, we need to come out with a negative 3. Right? When we add positives, we come out with a positive. When we add negatives, we come out with a negative. Therefore, these are the values we're going to use. -1, -2. And then, if we need to, we can test it. X times x, x squared, x times 2, or times negative 2, minus 2x, negative 1 times x, negative x, negative 1 times negative 2, positive 2. Combine like terms, we got x squared minus 3x plus 2, which is all knowing we wanted. Now that we know the factors of x squared minus 3x plus 2, and we know the factors of 2x squared minus 2, we need to find out the least common multiple. So, the least common multiple, we look at the factors that we came out with. We have 2. Okay, Genesis. What's another factor that we could write for the LCM? So 2 is one of them. What's another factor? Okay, 1 is a factor because you could factor out a 1 and you still get the same answer. But of the factors that we have here, like we have here this factor, we have here this factor, this is a factor, and x minus 1 is also a factor. What could we write, or what's another factor we could write down for the LCM? For the LCM, all we're doing is listing the different factors that have shown up within both polynomials. The factor we came out with, x minus 1, x plus 1, 2. X minus 2? Well, that's if you're if you're solving for the x's, instead of being to 0, you would get x equals to 1, x equals to 2, x equals to 1, x equals to negative 1. But all we're trying to write down here are the factors. So for the LCM, we need to write down all the factors that have come out with these two. So I'm going to write x minus 1, x plus 1, and x minus 2. Now the degree that we're going to have it is going to be based on the most times that this factor showed up within both of these polynomials. 2 showed up only one time in the first polynomial of 2x squared minus 2. So it's going to be the first degree. X minus 1 showed up once in the first polynomial. It showed up once in the second polynomial. Therefore, its degree will be 1. X plus 1 showed up once in the first polynomial. So the degree will be 1. X minus 2 showed up once in the second polynomial. So it will be 1. simplify these, if this is possible. But for now, having it in this, because they're all to the first power, you don't need to square it or anything. In the case of this lesson, it's fine to just write out the LCM in these terms. But if to simplify it, you would distribute 2, then you would multiply x minus 1 by x plus 1, which will just get you this, and then you multiply x squared minus 1 times x minus 2, and it'd be a polynomial to the 3rd degree. But this answer will suffice. What is this? Okay. Let's continue with the 4th question and just ask, does anybody have any questions? Okay. So, the 4th problem. We have y to the 4th plus 8y to the 3rd plus 15y squared. Coefficient of 1. Coefficient is 8. Coefficient is 15. There's no number that we could factor out of y to the 4th, 8y to the 3rd, or 15y squared. So let's look at the next term, which is the y's. We have y to the 4th, y to the 3rd, and y to the 2nd. Y to the 4th, y to the 3rd, and y to the 2nd. We could factor out y value. How many? Well, the 15y squared only has 2 y's. The 8y to the 3rd only has 3. Y to the 4th has 4. The greatest amount of y you can factor out of all of them, because it's addition, is 2. So we would write y squared, and the value that we get when we take away 2 y's from here, 2 y's from here, and 2 y's from here. We'd be left with taking away 2 y's from y to the 4th, it'd be y squared, eight y, 3 minus 2 is 1. And then 15y squared, taking away 2y, is just 15. This is a polynomial to the 2nd degree. We could solve for the factors in this polynomial by working with the factors of 15. 15, it has 1 and 15, 3 and 5, and then it just repeats 5, 3, 15, 1. The 15 is positive, the 8 is positive. We need to know whether, or which pair of numbers we could use that when multiplied give us 15, which are these numbers. When you multiply them, you get 15. 1 times 15 is 15. 3 times 5 is 15. But when you add them together, you get an 8. But we don't know whether these are positive or negative. We just know that it's a 3, a 5, a 1, and a 15. Well, the 1, if we let 1 and 15 go be positive, we get the sum of 15 and 1 to be 16. If we add, or we assume 3 and 5 are both positive, we get 5 plus 3, which is 8. And because we get 8 as our answer, we assume both of them are positive. We get 16. We get 8. And we compare it to our polynomial here. So when multiplied, we get a 15. Yes. When added together, do we get an 8? Yes, we get an 8 if we use 3 and 5, and we assume both 3 and 5 are positive. What would the factors be then? The factors of y squared plus 8y plus 15 would be y plus 3, y plus 5. And the y squared, we keep it on the outside. We have y squared, y plus 3, y plus 5. And these are the factors for y to the 4th plus 8, y to the 3rd plus 15, y squared. Now we need to figure out the factors for y squared minus 3y minus 40. Okay. So we have y squared minus 3y minus 40. We need the factors. Well, looking at the coefficient of each one, they don't have any common factor that we could factor out. This is a 1, this is a negative 3, this is a 40. So there's no, we can't factor out any number. Could we factor out any variables? Well, there's no variables here on the 40. So you can't really factor out y from 40. It is a polynomial, and we could solve for both the y's. Right. Y times y. Okay? Negative 40. We know that the factors of 40, long and numerous, we have 1, 40, 2, and 20. We got 4 and 10. We have 5 and what?
8.
8. Okay. Now this is a negative 40. The negative matters. So these two numbers, or these pair of numbers that we have, when multiplied, need to give us negative 40. And when added together, need to give us, negative 3y, or just negative 3. Someone want to volunteer? They've already worked this out. What pair of numbers we should look at first? Okay, Ashley says 5 and 8. should we give the negative to the 8 or to the 5? To the 8, okay. So 5 minus 8, we get negative 3. 5 times negative 8, negative 40. So it looks like it matches. So then our factors for y squared minus 3y minus 40, positive 5 and negative 8. Now we need to figure out, or we need to write the LCM write the LCM. We first write all the factors that have come out from these factors that we made for this polynomial and this polynomial. What are the factors that came out? Well, y squared is one factor. Y plus 3 is another. Y plus 5. And y minus 8, yes. Y minus 8. Well, I mean, I already wrote down the degree of y. So y came out at most 2 times, or y squared plus 8y cubed plus 15y squared. So the degree of y will be 2. Y plus 3 came out at most in either of these two, came out 1 time. To the first power. Y plus 5, it came out in both of them, but the most amount of times that it came out in either of these two, the most in this one, the most in this one, is once. It's to the first power, this one's to the first power, therefore y plus 5 will also be to the first power. And then y minus 8 came out 1 time, and the most amount of times it came out here was once. Therefore here too, it will be to the first power. And for the sake of this lesson, this answer is satisfactory. Okay, is there any questions? Can I continue, or is anybody writing this down still? Okay, so let's move on to the next page. These are just general definitions and information that we use when adding and subtracting rational expressions. Okay. LCD means least common denominator. Okay. To know what the LCD is of 2 rational expressions, you need to find the least common denominators, or the least common denominator of the 2 expressions that you're working with. So if you find the LCM of B and D, you will be able to know the least common denominator of A over B and C over D. As long as B is not 0 and D is not 0. Why? Well, a number over 0 is undefined. You can't have 1 over 0 or 2 over 0 or countless other numbers over 0 because that's undefined. We subtract, same thing. We find the least common denominator of these two. Once they have the same denominator, you can subtract them like regular, the way we would before. Okay? Now, we're going to add rational expressions. We have here 3y over 2x plus 2z over 5x. Okay? First, we need to find the LCM of 2x and 5x. 2x simplified is just 2x. 2 is prime number, x is just the first power. 5x, 5 is a prime.
As you're walking out, guys, I need to give this to you. This is your missing work. I need everything turned in by tomorrow if you want it in for report card. I will be here after school for tutorials. And Leo, don't forget to leave me my pass. Don't forget to leave me my pass. Yes, please give the name tags back to Mr. Cano. If you got your missing work, you can go.